The difference in proton dissociation behavior between a strong acid and a weak acid is that a strong acid would dissociate its protons completely when in water, while a weak acid will only dissociate its protons partially.
The difference affects equilibrium because stronger acids will fully dissociate into ions, meaning the reverse reaction cannot occur, thus an equilibrium cannot be reached. However, weaker acids only partially dissociate into ions, meaning both molecules and ions can be present in solution at the same time. Thus, an equilibrium can be reached.
A buffer is a solution made of a weak acid and conjugate base, or a weak base and a conjugate acid. Whenever acid or base ions are added to the buffer solution, they will form a weak acid, therefore resisting change in pH.
A buffer solution can be used to minimize the effects of the proton dissociation behaviors. Since a weak acid and its conjugate base, aka a buffer solution, will be present in a solution, the equilibrium can shift left or right to maintain a steady pH when a strong acid is added.
In the next few videos, you will see each of us demonstrate how to operate a pH meter. After removing the bottle and pushing the cap up the probe to avoid damage, we washed the probe with deionized water and then chem wiped. The probe was placed into solution. We tested the pH 7 solution first. We performed a 2-point calibration, so we selected this option. We entered the known value, 7, and waited for the reference number to stabilize. We then pressed keep. We then washed the pH 7 buffer off the probe with DI water and chem wiped once again. We completed the same process with the pH 4 buffer as we completed with the pH 7 buffer previously. We then selected apply to complete the process. Each member of the group tested both buffers, recording observed pHs as observed. Then, all items were properly cleaned. The probe was rinsed with DI water and chem wiped. All solutions were disposed of down the sink, and all glassware was washed with soap and water, then dried.